So Docker. So what we learn, guys? A Docker. So what is the why? So why Kubernetes? So what is a Docker? So what is a Kubernetes, guys? And what is the difference between a Kubernetes and a Docker? What are the drawbacks in the Docker? What are the drawbacks in the Docker, guys? So it should need to take this location. So what are the drawbacks in the Kubernetes? What are the drawbacks in the Kubernetes? First of all, something like a Kubernetes is easy. What is our motto? So Docker is easy. Understood, right, guys? Docker is a very easy. You understand the Docker, what is a container, how to start the container, how to create the Docker images, how to deploy the Docker containers, how to deploy your application. So Docker is very easy. So yeah. So something like a Kubernetes is easy. Kubernetes is easy. What is our motto, guys? Kubernetes is a very easy. So something like a what are the Kubernetes? So I will discuss later. We discuss. So discuss what is Kubernetes. Before that, we need to compare the drawback of the Docker, guys. So Docker. What are the problems in the Docker, guys? What are the drawbacks in the in the something like in the Docker? So they have a three or four drawbacks in the Docker. Four drawbacks in the Docker. So what are those Dockers? What are the problems in the Docker? So something like so so this is a VM, guys. This is a VM. You deployed a Docker containers. So something like so these are the Docker containers. Docker containers are running on this a VM, a virtual machine, or a EC2 instance. EC2 instance or a Docker machine. So something like these all are the containers. So these all are the containers, and these all are the independent. Independent. So these all are the independent. If someone, so every day we need to verify the Docker PS. So that the Dockers are running or if the Dockers is running or not. Something like your application is deployed on these containers. So these are independent containers. So there is no manager to manage this containers. There is no management to manage the container. So it is a independent. So it is a independent. If something goes down, if this application is if the deployed in this container, the your application is deployed. This Docker is content count. This goes down. So who will tell you? So no one can tell you. So something like your application goes down, right? Your application goes down. Again, you can verify by using the Docker PS. Then you can run the Docker container. So they then run the Docker container. So something like it is a so the problem is something like the first problem is something like a so not get started automatically. What is the problem, guys? Not get started automatically, right? So not get started automatically. So the not get started automatically something like a single host nature of the Docker container. So what is this, guys? A single host nature. This is not dependent. This is the independent. Single host nature of the Docker container. Single host nature of the Docker container. So what is it? Not get started automatically. So if pause goes down, so we need to check it and we need to start it. So this is one of the drawback in the Docker. So usually so whenever you deploy an application in the production, whenever you deploy application in the production, so the not get started automatically. It's not get started automatically. The second one is the second drawback is something like a auto healing. What is that, guys? Auto healing. So what is auto healing, guys? Something like so if something goes down, if something goes down, so it will not healing. It will not healing default. So something like it will not healing the healing. So something like if Docker if the container goes down, so we need to automatically start the Docker. Need to automatically start the Docker. So that is nothing but a auto healing. So if something goes wrong on the Docker container, it will not automatically restart the pods. It will not restart the container. So that is the second drawback. So what is the third drawback? So third drawback is nothing but a auto scaling. Auto scaling. So something like your application. So something like your here. So your application, your container is deployed in this in this server. So something like so the usually the U limit of the server something like a 10,000. The U limit of the server is 10,000. So that big million Indies. For example, this is the a e-commerce site e-commerce site. So something like in big million days or something like in festival days, there are many people are logging to this portal and order the number of places. That time the people are joining, but there is an issue with. So there is no something like the limit is 10. So if we say auto scaling group, it automatically so auto scaling is nothing but a load balancing. It automatically spin up another container and shares the load. That is nothing but a auto scaling. So this is also a drawback of the Docker. Docker. There is no there is no auto scaling. There is no auto scaling feature in the Kubernetes Docker. There is no auto scaling feature. And so that something like it's not a enterprise level. It's not a enterprise support. Enterprise support is nothing but so it's not a enterprise. Was this guys? Enterprise. So enterprise. So it's not a enterprise. Docker is a simple platform. It's a simple platform. Simple platform. It's not support. It's not support the entire enterprise level. So when we deal with the big application, something like a big application,
Alpha.
so it will not support. It will not support, guys. Hi, someone is asking something,
No.
right? So enterprise, it's not support the enterprise. It is not auto scaling. It is a auto healing. So it is not get started with automatically when the pods are down. So these are the drawbacks in the Docker. Who will solve these problems? Who will solve this problem? Who will solve this problem? The solution is, guys, Cube. The solution is, so who solve these problems? Who solve these problems? So something like a Kubernetes. Who will solve these problems? We called as a Kubernetes. Guys, tell me, what are the drawbacks? Four drawbacks. Tell me, guys, what are the four drawbacks, guys? Not get started when it goes down automatically. It is not get started. So then is auto healing. There is no support of auto healing. Then is auto scaling. There is no support of auto scaling. So it's not an enterprise level support. Docker is not supported for the enterprise level. Docker is not supported for the enterprise level. Guys, understood? So these are the drawbacks. So who will solve these problems? So who will solve these problems is Kubernetes. Kubernetes will solve these four problems. Will solve these four problems. Guys, understood? Guys, remember these four. So we will talk it in future also. So something like a enterprise. So something like enterprise is nothing but so enterprise support is nothing but a load balancing. your applications is having a load balancing in the firewall. Firewall is nothing but a networking, something like a auto scaling, something like a API gateways, API gateways. So there is no support these. So the solution is called as a K8s. K8 Kubernetes is solve these problems. Kubernetes. So these all are the enterprise level standard. So enterprise level standard. So we will see who will solve these problems. So we will solve these problems, guys. Kubernetes will solve these problems. In general, it's a master, master node architecture. Kubernetes is a guys. In general, Kubernetes, Kubernetes is a master and master node and a worker node concept. So basically, it is a something like it is a master node architecture. So what is a cluster, guys? What is a cluster? So cluster is nothing but a group of nodes. What is not, guys? Group of nodes. What is nothing but a cluster? So Kubernetes, a cluster. Kubernetes supports a cluster. So what is a cluster? So you see, so the 4 points one is a single nature, single platform, something like a it's not started automatically, it's a single host nature. But the Kubernetes is a group of nodes nature. It's a cluster. What is a cluster? So something like our Dockers are deployed in a single EC2 instance, so the container. So this is a single host nature. So this is a single host nature, but Kubernetes are deployed on a group of nodes. Group of nodes. No, a node is nothing but a instance or a VM. So VM. So this is also VM. This is also VM or EC2 or EC2 or EC2 instance. So a group of group of nodes is called as a cluster. So group of nodes called is a cluster. A, a cluster. Guys understood, right? It's something like a master and a worker nodes. So Kubernetes is a master nodes and a worker nodes. So worker nodes, the concept. So something like now you understood what is a cluster. So going forward we are using the cluster, guys. So now you understood, right? What is a cluster? Cluster is nothing but a group of nodes. A group of nodes is nothing but a cluster. So something like a so what is a faulty node? So something like a faulty node in the doc in the VM something like it goes down. So who will take care? Who will take care, guys? So no one can take care of this a VM or a node. So in the Kubernetes, if node goes down, it will create another node. If pod goes down, it will create another pod. So that is the nature of the Kubernetes. That is the nature of the Kubernetes. It will create a new nodes or a pods. But in the Docker, it is not possible. But in the Docker, it is not possible. But in the Kubernetes, it will possible. It automatically create a node. It automatically create a parts. It automatically create a parts. That is nothing but a faulty node. It is nothing but a faulty node. So something like a replication controller. You don't know, guys, this, but you can remember this. So replication. So So replication controller. So what is a replication controller, guys? So replication controllers is nothing but a replica set. So replica set. So something like if in this node, so we have a two pods. We have a two pods. Two pods. So something like a replica set, something like a two pods. Kubernetes replica set, something like a two pod. If something goes on the one pod, it automatically spin up another pod. That is nothing but a replica set. So that is nothing but a replica set, or nowadays we are calling it as a replication controller. So replication controller. So the container increasing the traffic. If the container increasing the traffic, If the container increasing the topic, something like a when beginning index, it automatically spin up a. So this is a C1 container, this is C2 container, this is second container. So if something goes a traffic issues topic, it automatically spin up the other containers. That is nothing but a replication controller, or a replica set, or a replication controller. So something like replica set is an YAML file or replication controller file. It is so in the file YAML file we will specify so the replica set of the parts. We will separate of the parts. So in Docker we are calling as in container we are so in the Docker we are calling as a container, but in the Kubernetes we are calling as a pods. Guys, we will discuss later this. So when we do the architecture, so we will discuss this. So this is so what are the drawbacks? What are the advantages in the Kubernetes? So what are the advantages in the Kubernetes? So something like auto healing concept is nothing but a faulty no. So something like the increasing of the auto healing auto scaling is nothing but a replication controller or a replica set. So something like a heal. The Kubernetes control and fix the damages. Kubernetes so Kubernetes, what is a healing? Healing. What is a healing? Kubernetes controls and fixes the damage is nothing but a auto healing. So auto healing is nothing but a Kubernetes. So Kubernetes controls and fix the damages. Fix the damages. But in the Docker, so who will fix the damages? So there is no possibility to fix the damages. There is no possibility to fix the damages. So what is meaning of a auto healing? Something like if container goes down as a feature called as a auto healing, it goes down, it automatically start a new container. If goes down, it automatically starts a new container. Starts the container. So something like a roll out a new container, something like Kubernetes roll out a new pod or new container if something goes down. So that is nothing but a auto healing. So something like Kubernetes. Yeah. So Kubernetes, something like a Kubernetes. Who designed, who created, who developed by Google, developed by the Kubernetes. Google developed by the Kubernetes. So something like Google also created a language called as something like a Borg. What is this, guys? Borg. So Borg is nothing but it's a community. So it's an enterprise level. It's an enterprise level solution. So this is a enterprise level solution. So they're still evaluating this Borg. So Borg is not a open source control tool. It is a something like a enterprise and even a better solution for the Kubernetes guys. So enterprise level architecture platform. So what is Kubernetes? Kubernetes is a enterprise level architecture. Enterprise level architecture. Kubernetes is a enterprise level architecture a platform. So what are the advantages, guys? What are the advantages? What are the advantages in the Kubernetes, guys? Guys, I already told you, right? What are the four advantages? So what are the four advantages, guys? Tell me. So the drawbacks is a advantage in the
Why,
Kubernetes.
why should be auto healing?
So the advantage in the Kubernetes. So something like this is a cluster in nature. You also know what is a cluster. A group of clusters is so Kubernetes is something like a master node concept. Kubernetes is a master node concept. So it is a cluster. A group of nodes is nothing but a cluster. And the auto healing concept. What is that? Auto healing. So Kubernetes will deals with the auto healing and the auto scaling. Auto scaling is nothing but it will automatically spin up the containers and it's a enterprise architecture. What is this, guys? This is a enterprise architecture. It is a enterprise architecture. So Why Kubernetes is popular? Kubernetes is popular because of these are the advantages. So these are the advantages. Why Docker is why Kubernetes is popular than Docker? So these are the advantages in the Kubernetes. These are the advantages in the Kubernetes. Guys, understood? So cluster in nature, auto healing, cluster in nature, and enterprise architect level. Enterprise architect level. Yeah. So what is the Kubernetes architecture, guys? So what is the Kubernetes architecture? So Kubernetes architecture. So Kubernetes architecture is something like a control plan and a data plan. So control plan is nothing but a master node. A data plan is nothing but a worker. So what is the architecture of the Kubernetes? So architecture of the Kubernetes is worker node and something like a master node and worker node. So worker node is nothing but a control plane, and master node is nothing but a control plane, and worker node is nothing but a data plan. Data plane. So worker node is nothing but a data plane. What are the components in the what are the components in the control plane, and what are the components in the worker node? What are the components in the worker node? What are the components in the worker node? Something like what are the components, guys? API server, HCD, etccd, HCD, and scheduler, and controller, and cloud control manager. In the data plane, kubelet, proxy, so kubelet, proxy, and container runtime. These three are the, so these three are in the worker node. So these three are in the worker node, guys. So worker node, guys. So something like in the Docker container. So Docker container. So this is the container. So this is a container. Container is running. So container Docker container. So how we can run the container Docker run? So something like this is a Docker container. How who will handle this a Docker container runtime? A Docker container runtime will handle the Dockers. So same like a Java runtime. So JDK gets something like a Java runtime. Java runtime handles the Java. Same like as a Docker handles the Docker container runtime handles the Docker container runtime handles the Docker container. Docker container. Something like so it is call it as a Docker runtime, call it as a Docker stream. Docker stream, guys. So something like the Kubernetes. This is the Kubernetes. So Kubernetes is a master and worker node. So master and worker node. So this is the architecture of the Docker. But this is the architecture of the Docker is, so there is a master node and a worker node. So master node is nothing but a control plane. Master node is nothing but a control plane. So that worker node is nothing but a data plane. So in the worker node, in the YouTube or something like on the portals are they are telling a number of YouTubers or something like a number of the writers, content writers, they are writing the, so what is the architecture of the Kubernetes? But so I will simplify this. I will simplify the architecture. You will understand the architecture of the Kubernetes architecture. So what is this? So so here, so we are deploying a pod nature, guys. We are deploying a container. So here a pod. I will tell you, guys. Later I will tell you what is a pod. I will tell you this is the pod. So pod is so handle this? Who will handle these pods? We will handle the pods as a container runtime. So who are the container runtimes? Container runtime is nothing but a container D. So container D, CRIO. So container Swift. So these are the number of container runtimes, guys. This container runtime is something like it will run the container or something like a run the container. So and the so pod is running. Something like a pod is goes down. Who will who will verify this? in the Docker. Docker, no one verify the if the Docker goes down. So something like manually we need to execute the Docker PS. Then so then when will wait then you can run the Docker run, right? But in the Kubernetes there is a kubelet service. It continuously verifies that if the pod is running or not. If the pod is running or not, it continuously verifying it. It continuously verifying the if the pod is running or not, and the kubelet verifies the pod is running or not. If something goes wrong, so this will inform to the some other person. I will tell you guys later. So this will inform to the some other person. And the kube proxy. What is the kube proxy? Is nothing but a kube proxy is nothing but a IP address. So you want to assign a specific IP address to the pod. Who will take care of the IP address, IP addresses assigning? Who will take care of the IP addresses and everything? Kube proxy will handle the networking part. So proxy will handle the networking pod. Kubelet will handle it verifies if the pod or container is running or not. If the container is running or not. If not running, so that kubelet is informed to the some other guy. Some other guy in the master plan. Will tell you guys. So you guys are understood. What is the container runtime and what is the kubelet? What is the kube proxy in the worker node? So what is the architecture? What is the architecture in the worker node? So we have a three guys. We have a three. Kubelet. Kubelet will verify if the pod is running or not. So if not running, it will inform in the master node. It will inform in the master node some other service. The kube proxy. Kube proxy. Kube proxy is so something like if it will be verifying the IP address of the assigning the IP addresses ports and the network part will taken care by the kube proxy. Kube proxy is from the network network. So container runtime. So you already knows, right? A container runtime is for controlling the containers. If the container is running or not, like the pod is running or not. So if your container is nothing but a container D. Container D is nothing but a Docker service, right? If the Docker service is running, then only we will we will we will deploy our pods or something like a container, right? So this is nothing but a data plan architecture. Now you understood, right? This is a simple three definitions for in the worker plane. So one is kubelet. Kubelet is verifying if the containers, if the pods are working, if the pods are running or not. If not running, it will inform to the master node. So master plane, control plane. So kube proxy is receiving the IP address of the IP address. It is networking part. We will handle the kube proxy. So container runtime. So this is the container service running for the run the containers. Run the containers. So this is nothing but a worker plane, guys. This is nothing but a worker plane. So next, a control plane. So what is the components in the control plane? So usually, Docker no need to have the a master node. It automatically runs without the master, right? Without the master because of so there is no maintenance, there is no management to run the Docker. So here the Kubernetes will manages or maintain the will maintain the or will monitor the your containers. Will monitor the containers. So in the master node, we have a components called as a API server. Something like this is a API server. So the other one is a scheduler. What is this, guys? Scheduler. So the other one is a HCD. The other one is a HCD. The last one is a controller. Controller. So something like what are the architecture, guys? Something like these are the API server and HCD and the scheduler and the controller and the controller. So you understood the architecture about the kube proxy, kubelet, and container runtime. So this is the worker node architecture. So what are the components are there in the worker node? These are the components. So something like in the master node, So what are the components are there in the master node? So something like so this is the core component. So this is the core component. Core component is API server, API server. So what is a API server? API server will manages the, so the details will be located in the, something like that will manages the, so we'll manages the everything in the master node. So we'll manages the, so this is the API server. API server having the all the details, all the details in the details about the work, the master node. So all the details about the marker node. So this is a handling everything. API server is handling in the everything. So something like if something goes wrong on, so who can inform? We can inform to the core component. The core component is this API server. We will inform to API server. API server will inform to the scheduler. So we'll inform to the scheduler something like if the pod is not running, is the pod is goes down. So who knows? So the kubelet will inform to the API server. API server will inform to the scheduler. Scheduler will check if the pod is not running. It will automatically start the pod. So scheduler will schedule this. So what is a HCD? So HCD is nothing but a the data. So something like the data or backup plan will be available. The data is available in the all the key and store values. Key and store values will be stored in the HCD. If scheduler will start the pod, right? So just inform to API server. API server will inform to the scheduler. Scheduler will check it in the HCD. So what is the replica set? What is the replica set or replication set? Something like the replica set is 2. Replica set is 2 is nothing but a, so we need to run the 2 parts at any time. We need to run the 2 containers at any time. So one container is down. So it verify in the HCD. So some the key and master. So this HCD something like there is a replica set is a 2. It automatically the another part. In the replica set, the node is 2. If node goes down, it automatically scheduler will up the yeah. So something like a controller manager will control the something like everything. Everything will controls. The controller will everything will verify the replica set and everything. It will handle the controller. So HCD only contains the key and store values, but control having that something like a control having the replica sets. Controller having the replica sets, and will it uses the replica sets. So with the scheduler, it will up the servers of the container. So this is nothing but a Kubernetes architecture. This is nothing but a Kubernetes architecture. So you guys have understood, right? So just simple terms, guys. The simple term, it is a Kubernetes architecture. The simple terms, it is a Kubernetes architecture. I will show you guys. I will show you it in the yeah. You see, so Kubernetes also known as a KTS. It is as open source container management tool. It provides a container runtime. Yes, container runtime, container orchestration. Yes, container orchestration, container centric infrastructure orchestration. Yes, container centric infrastructure. Self-healing mechanism is nothing but a auto healing, and service destroy, and load balancing is nothing but a auto scaling, something like a container descaling. So initially deploy the Google for managing the containerized application in the cluster environment. You guys also know about the what is the cluster. So cluster is nothing but a group of nodes. Group of nodes. Initially developed by the Google for managing the containerized application in a cluster. So environment, but the later donated to CC and now. So written in Go language. It is a platform designed to completely manage the lifecycle of containerized application. The lifecycle containerized application. This is the lifecycle of a containerized application. So Kubernetes we already discussed, right? Kubernetes, a certified Kubernetes admin distributions. So what are those? A cloud managed the EKS, EKS by AWS. EKS is nothing but Elastic Kubernetes Services, and AKS, Azure Kubernetes Services by the Microsoft, and GKE. So Google Kubernetes Engine by the Google. So self-managed is nothing but OpenShift. This is by the Red Hat and Docker Enterprise. And the local dev and test environments, so something like micro Kubernetes by Canonical or Minikube. So local purpose we are using the Minikube and the Minikube. So this is the enterprise edition. So enterprise edition we need to purchase. So if we want to use the local environment for the dev and test and QA prod, so we can use the micro Kubernetes by a Canonical or Minikube. Most of the people are using the Minikube guys in our local environment. So vanilla Kubernetes, the core Kubernetes of the project, something like a bare metal, kubeadm, special builds K3s by Rancher using the K3s, a lightweight Kubernetes distribution for the edge services, edge devices. Yeah. So Kubernetes cluster. I already told you, right? So Kubernetes cluster is a set of physical or virtual machines and other infrastructure resources that are needed to run your containerized application. Each machine is in a Kubernetes cluster is called as a node. So this is a master node and worker node. This is nothing but a cluster. Both master node, worker node is nothing but a cluster. In the cluster, so each machine is in the Kubernetes cluster is called as a node. Something like this is a master node. One is the EC2 instance. So this is also a EC2 instance of a worker node. So there are two types of nodes in each cluster, each Kubernetes cluster. So master nodes and cluster nodes. So what is the master node? Master nodes host the Kubernetes control plane components and manages the cluster. So this is only host the Kubernetes control plane components and the manages the cluster. Who will manage the cluster? These two nodes. A group of nodes is nothing but a cluster. Who will manage the cluster? Who will manage the cluster? Master node will manage the cluster. So worker nodes run your containerized applications. So in the worker node, your applications will be deployed in the worker node. Your applications, your microservices will be deployed in the worker node, and the master node. So will manages this worker nodes. Who will manage the worker nodes? A master node will manage the worker nodes. But in container, so there is no solution for the auto management. So managing. Right. So Kubernetes architecture. So this is the Kubernetes architecture. I will simply explain this, what is the master node and what is the worker node. So master node is to call it as a data plane. So master node is to call it as a control plane, and the worker node is called it as a data plane. So what are the components in the data plane and what are the components in the marker node? So for example, this is the Kubernetes architecture. In the Kubernetes architecture, master node. So here we have a two worker nodes. So this is nothing but a cluster, a group of nodes, something like a master node, worker node 1, worker node 2. See, this worker node is nothing but a VM or EC2 instance. This worker node 1 is nothing but a VM or EC2 instance. This worker node is nothing but a any EC2 instance. So these are the three EC2 instances running. So a cluster is nothing but a group of nodes or group of VMs or group of servers or group of EC2 machines is nothing but a cluster. So master node. So master node, I already told you, right? A master node will manage the worker node. Who will manage the worker node? Who will manage the worker node? The master node will manage the worker node. What are the components in the worker node? I already told you, right, guys? Proxy, it is this proxy manages the IP addresses, ports, everything. Network part. That kubelet is this kubelet is responsible for the containers are running or not. Containers are running or not. Something like the Docker container. A Docker container is running. So something like this is the container runtime. So this is the container runtime. This is the proxy. This is the kubelet. So in this Docker container, how many containers are running? Something like a pods. In the pods, containers are running. So kubelet verifies the containers are running or not. Kuproxy will is responsible for the networking, and this is the container runtime. This is the container runtime Docker services running. Docker services running. So these are the two worker nodes. These are the two worker nodes in that worker nodes having the pods. The pods having a pod content. Pods having a proven content. So master node. So master node. So master node, in the master node, what are the components are there? In the master node, I already told you, right? That guys, API server, HCD, a scheduler, control, scheduler, controller. So something like here you see. So the API server, the scheduler, HCD, and controller. HCD and controller manager. So scheduler, controller, HCD, and API server. So the heart of the master node. Who is the heart of the master node and cluster? Who is the heart of the cluster? The heart of the cluster is API server. So everything will inform to the API server. Everything will inform to the API server. API server having the all the information about the master node, cluster node, and work node. So so once the something like the container is not running, the kubelet validated. So something like a container is not running. So this will inform to the API server. Kubernetes inform to the API server. API server will inform to the scheduler. So yeah, so scheduler you can check it if it is running or not. So if not running, you can run it. So scheduler so on the API control, it's also NPI control. So how many containers will need we are running in the replica set in the controller. So take the API server. So there are two containers running in the API server. Then HCD. The key and store values will be the database value, the database, everything will be stored under the HCD. So these are the master nodes. These are the worker nodes. So kubectl is the CLI command to connect to the master node, and web UI is also there. So what are the web UIs, guys? For example, so web UIs, for example, guys. So web UIs, for example, tell me. We cannot write here. For example, this is the master node, this is the worker node. So there is a internal. Yeah. So something like this is a master node. So this is a master node. So this is the master node. These are the worker nodes, guys. Worker node one, worker node two. So something like I want to deploy I want to deploy a container in the worker node. I want to deploy a container in the worker node. Something like how we can deploy it. So this is the so this is nothing but a inner of the inner of the application. So this is the outer of the application. So who told something like you are the guy, you are informed to deploy pod in the worker node. So this you will inform to the master nodes. Master node will automatically deploy your application to the worker node. So how we can connect these master nodes, how we can connect this master node either by using the CLI or by using the GUI. So we can connect a master node through CLI or through GUI. So what are the GUI components is guys? AWS is provided a EKS. This is a GUI, and Azure provides a, guys tell me, AKS. This is a GUI solution. So Google provides a Kubernetes engine, JKE. Oracle also provides OKS. Oracle Kubernetes. So OKE, okay. Oracle Kubernetes engine. There is a other third-party tools are there. RK. So RK is so Rancher, so we can deploy our application either GUI or a CLI. So what is the CLI command, guys? Cube, kubectl. What is the command, guys? A kubectl command. You see, kubectl. So we can manage either CLI or we can manage either web UI. So I already told you, right? So what are the web UIs and what are the so the command is, guys, kubectl. So kubectl. So something like a kubectl. Yes, okay. Yeah, yeah, I'm taking kubectl get pods or kubectl get nodes. So it will shows the pods running or not. It will shows the nodes. Node is nothing but these are the nodes. So kubectl get pods, but in the GUI we can go to the API. API is nothing but application interface. There is application interface for data center, right? AWS API console. The same like as a so here having a API, EKS, GKE, OKE, or Rancher. You can go to this application and you can you can automatically use the GUI option to use the something like you need to get that parts. So it will show in the GUI. Or even like you want to deploy it. There is an option redeploy or deploy. So there is options are there in the GUI. You can if you click this deploy, it automatically deploy. But in the kubectl compose or kubectl deploy, we can use the commands. So something like the same like as a git GUI. What are the GUI solutions? Git is a CLI and the GitHub, GitLab, Bitbucket. So if you can push and pull the code either GUI or a CLI. Same like as a kubectl is the CLI commands and these are the GUI. These are the GUI, guys. So because of a Kubernetes is a open source. Open source means so we can took the code and we can design whatever it may be. We can design by using the GUI or we can use a CLI. Guys, understood? Little bit you understood about the Kubernetes, guys. Right, guys? Guys are understood? Guys, speak out.
Yeah.
Yeah.
Yes.
Yeah. Yeah.
Yeah. So something like a Kubernetes architecture, Kubernetes components are something like a HCD, API server, control manager, scheduler. So these are the Kubernetes master components and node components, something like a kubelet, so kube service. So master, so Kubernetes master. So what is master is responsible for the managing the complete cluster. And you can access the master node via CLI or GUI or API. The master watches over the nodes in the cluster and is responsible for the actual orchestration of the container in the master node. So for achieving fault tolerance, there can be a more than one master node in the cluster. So it is an access point from which administrator and other users interact with the cluster to manage the scheduling and deployment of the containers. So it has the four components: HCD, scheduler, controller, and API server. What are those four components in the HCD, scheduler, controller, and API server? So something like a Kubernetes architecture master. What is HCD? What is a scheduler? What is API server? What is a controller manager? So guys, so we'll discuss on this Monday. You just learn the what is the architecture, how it works. What is the architecture? How it works. So Kubernetes is a orchestration control, orchestration management tool. So you understood, right? So why orchestration? It
Yeah.
is a managing all the components. It manages the components. Docker is not a orchestration. Docker is a independent in nature, but the Kubernetes is independent nature with the master and work components. So it is a cluster. So it is a cluster. They are having the a cluster component cluster, auto healing, auto scaling, and enterprise level. And then enterprise level. You guys understood? So what is the different why API, why scheduler, why HCD? I give a overview of the what is scheduler, what is controller, what is. So Monday will read you the all the components and will show you how it works. kubectl. Kubectl is the master nodes. So kubectl is a command line utility which is we can interact with the cluster. So uses API provided by the API service interact. Also now we'll show it to you guys. kubectl run, kubectl custom info, kubectl guest nodes. These are the CLI command. Kubelet, kubeproxy, what is the kubelet, what is the kubeproxy, Kubernetes, what is K3s, we'll show you guys. We'll show you the K3s in mini cube pods, what is a pod, the pod contains, so scaling pods, so imperative and declarative, how we can write the our Kubernetes YAML files. So we'll show you guys. We will deploy in, we will install in the one of the nodes, the EC2 instance, guys. Then we will show you what is this. Okay. Now you got it right, guys. Okay, but nowadays Kubernetes is most useful tool. Everyone is using. Everyone they're deploying their application in the microservices model, and they are using the Kubernetes. They're using the Kubernetes, guys. Understood, right? Understood,
Yes.
guys? Yeah.
Yeah.
Yeah. So you understood
Sorry,
Kubernetes?
please.
Kubernetes. Yes.
Yeah.
Yes.
Can you
Tell me.
send the Docker file document? I was searching for the comprehensive list of Docker file, like some of those commands and the definitions. Where did we keep it? You can forward it to the WhatsApp.
Yeah.
WhatsApp
WhatsApp.
group.
I keep it in the WhatsApp, right?
No, I didn't see it. Unless it's the one that is not opening.
You did not see, the WhatsApp.
That is not opening. Like remember when you are teaching, you show us the Docker file, the definition, what is the meaning and all that. So it wasn't showing fully the way you showed us the thing
Okay,
during the
okay. This
time we
one
are
you are
talking.
asking about.
Yeah, yeah, like it's not showing this kind of thing. Yeah.
Okay, I will upload. I
So
will
what?
upload. This is right. You are asking about Docker.
Yeah, 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 yeah,
You
yeah.
are asking
All
about
this
the
thing.
Docker. Yeah, yeah.
Yeah.
I will upload this. I will upload this.
Okay, thank you.
Yeah. You are not seeing, right? I will upload this document.